All right, a common scenario when utilizing the time value of money is trying to figure out how much money we would actually have to save for retirement. So in this video, we're going to be utilizing the future value of an annuity equation to try to figure out how much money we would have to save to reach a retirement goal. Now, this is a very applicable question because all of us have to wrestle with kind of how much we, want to have at retirement at our disposal, but then kind of work backwards and figure out if my goal is $1 million or $2 million or whatever amount it might be, what do I have to do now to put myself in a position to be able to attain that goal? So we can actually use the future value of an annuity as a way of determining that. So what we're going to be doing is walking through a simple but very applicable financial problem. And then going through that, you're going to identify what are the steps that you would need to take to determine this on your own. So it's very simple, but there's a couple of steps to it. So first of all, we're going to be utilizing the future value of an annuity equation. So we're not going to be utilizing a financial calculator, which makes things much easier, or utilizing a financial table. So the question that we have here is we want to retire in 25 years with $1.5 million. Now, assuming we can earn a 10% annual return on our investment, how much will we need to deposit each year to reach our retirement goal? So there's a couple of things that we want to key in on. Now, whenever we're working on a problem such as this, it's always really helpful to identify the variables that we know. So I'm going to go ahead and list these over here to the side here. So the first thing is we actually know how much money we're trying to save for, and that's the $1.5 million. So in a lot of the future value of an annuity equation, as we go through it, this is usually the outcome of our calculations, but instead we're actually going to be trying to figure out one of the inputs, meaning how much money we have to save to actually get here. We also know our interest rate that we are assuming we're going to be able to earn, which is 10% annually. The last thing is we know the number of periods, which for us we express as little n, and that will be 25 years, or 25 to represent 25 years. Now, the variable, the thing that we don't know, is payment, which we show as PMT. That is commonly the acronym that is used, or the notation that is used on your financial calculators if you're using a financial calculator, which is PMT. So just trying to be consistent with that terminology. So this is the unknown. Now, kind of filling this in, let me go over what the future value of an annuity equation is. And that's what we call FVA, and that equals PMT, and then in brackets, the result of 1 plus our interest rate to the nth power minus 1 divided by our interest rate. Now, this looks kind of confusing, but we're going to walk through it step by step to figure out exactly what we need to do. Now, from a graphical sense, and I always like displaying things on a number line because it makes it really helpful from a visual representation standpoint, right? Trying to figure out actually what are we doing here. Part of the problem is getting into the weeds with the numbers. We might get the right number. We're not quite sure what this means or what direction we're trying to take. So if we were to express this on a number line, let's say, let me switch colors here. So let's say this line represents just time, and over here this is 0, so this time represents present, and here this represents 25 years from now. So what we're trying to accomplish here is we are trying to determine how much money or how much we'd have to save in order to get to 1.5 million. And up until that point, or up there, we have all of these years. So 1, 2, 3, 4, and 5. So on and so forth. And so what we're trying to figure out is for these periods every year, what does our deposit look like that collectively is going to get us to this $1.5 million figure right there. So we're going to walk through how to do that. Now, we're going to use a little bit of algebra here because, as you can see here, the equation as it's listed is solving for the future value of the annuity. Well, in this case, we kind of know that already, right? We have 1.5 million, but with a small adjustment utilizing basic algebra, we're going to be able to modify the equation so that we can figure out how much do we have to save on an annual basis. Now, I do want to convey as well that we are looking at things on an annual basis. And so if you were trying to figure out how much money you'd want to save per month, you're going to have to make some modifications to that. Also, the interest rate that you would earn, we'd want to take this 10%, we'd want to divide it by 12. That would actually help us. And then, of course, the number of periods, we want to multiply that by 12. So a little bit of adjustment there. Not super difficult, but obviously we've got to make some changes if we're changing how frequently we're making deposits, which more often than not, you're going to be making deposits on a monthly basis versus an annual basis, truthfully. So the first thing we want to do with any quantitative sort of question is we want to fill in the variables that we actually know so we can identify what are the things that we don't know. So for starters, let's just go ahead and fill this in. So our future value of an annuity, that's 1.5 million, and I'm just going to abbreviate that as 1.5 M, and that equals PMT, which is what we're trying to solve for. And then in parentheses, we have 1 plus 0.1. Now, an important thing is whenever you're working with percentages, we always want to convert them into decimals. If you don't do that, you're going to get a just very unrealistic number that on the surface is not going to make sense, which is usually a good sign that you're a little off somewhere. So go back and check your math. Typically, when I see students having problems with these types of equations, usually it's a matter of keeping a percentage in percentage form and not moving it into a decimal, which is a small thing, but it makes a big difference. And we're going to take that to the result of that to the 25th power, subtract that from 1, divide that result by the interest rate again, which, let me go back here, is 0.1, and that's it. So what we can start doing is solving for some of the variables that we have here. Now, what I'd encourage you to do is kind of follow along and do this on your own. So you have a calculator on hand, go ahead and go through that math. And so we know that 1 plus 0.1 is going to be 1.1. And then we need to take that to the 25th power. So there's a couple of ways to do this. There's a very tedious way, which is you just continue to multiply the number by itself 25 times, which honestly, there's going to be probably a lot of human error involved with that. So on your calculator, you probably have a Y with an X opponent kind of button that looks something like this. It's got the Y and then it has the X up here. That is what you'd want to use here. And so if you take 1.1 and then you hit that button and then you insert 25, you're actually going to get 1.0, I'm sorry, not 1.10, 10.8347. And then we can subtract that by 1 and then divide that by 0.1. So just to keep things simple, we know that subtracting by 1 is going to get 9.8347, right? So we're looking right here. And then we're going to divide that by 0.1. That should get you 98.3471. Now, just a note here on rounding. I get this question a lot. We don't want to round just yet. Typically, we want to round the final result, and we typically do that to the 100th. But you don't want to round your inputs, those variables, because that can have a very significant effect on your outcome later on. Now, if you're just doing this for kind of your own purposes and not for some type of assignment or project, it's probably not going to be that big of a deal. But if it's for some sort of grade, obviously being accurate is extremely important, and getting the right answer is really important because you're graded on that. So now we're at 98.3471. So let me go ahead and write out real quick, and I'm going to change colors again. What we have so far is 1.5 million equals PMT. And then in brackets here, we've got 98.3471. So this is where we have to solve for the unknown variable. So kind of just basic algebra. In order to solve, we have to isolate what we're solving for. So what we would do is we would take this 98 and we would move it over here. And as a result, that changes the expression. So instead of being multiplied, now it's divided by. So that would mean that we're going to take this $1.5 million and we're going to divide it by 98 0.3471. Now, once you do that, then we just have to do basic division here, and our end result should be $15,252.10, rounding to the nearest hundredth, of course, which I've already done here. Now, if you haven't done the calculations already, please do pause the video, go through that process here. You should be getting this number, again, assuming you're not rounding ahead of time before we get to the final number. So this represents the amount of money that we would have to actually save each year for retirement, assuming, of course, that we are getting a 10% annual return over the 25-year period, and assuming we're going to be doing this for 25 years. So there are some assumptions built in here. Ultimately, we're never going to be 100% accurate because there are a ton of variables with regards to investing that are out of our control. But again, we're trying to kind of hedge our bets a little bit and try to get close. It's, at least for purposes of saving, it's not meant to be 100% accurate. Just try to help us be able to make decisions here. So this could be a realistic number. It could be an unrealistic number based upon kind of your financial situation. So then you can take this number and divide it by 12 and do that sort of thing, or modify the equation entirely. But in order to, the big things are when trying to determine how much money to save for retirement, again, utilizing this future value of an annuity equation makes it really simple. And then with some basic algebra, again, solving for the annual payment, we can figure out how much money we need to put away and save for retirement.